here on this computer. So we did question 1 and 2 in class, yes, on last week, Wednesday. So we're going to continue with question 3. I did call you guys to go home and try to do question 3 on your own. Don't know how many of you did it. So again, we're going to go through the hypothesis testing here. There are 7 steps in this case. So read this question, number 3, and there should be what we call as a claim statement in your test in this question here. So go ahead, read the questions here and underline or highlight the claim statements that we have. There should be one of those. Okay. Anyone found a claim statement?
A politician claimed that people don't really understand the stem cell issue, and their responses to such questions are random responses, equivalent to a coin toss.
That's not the claim statement. That is the politician claim.
Oh, I think I found it. Claim that the proportion of subjects who respond in favor is equal to 0.5.
So this is the claim statement, yes. Okay, so that is a claim statement. So make sure that there are 2 things. One is talking about the politician claims about this stem cell issues, where it's equivalent to a Turing cost. What's the meaning when I say equivalent to a Turing cost? A Turing cost means that you can get head or tails. It's 50-50. So that's why. So in this case, the statement in this case is those who respond in favor is equals to 0.5. So we have to go through the whole 7 steps of hypothesis testing. So the first step we need to do in this case is the requirement check here. The requirement check in this case is simple random sample, a binomial, has to be at least 5 success and 5 failures. This is your first requirement check. Can someone read this question and point out, is this a simple random sample?
I think it is.
Armin, why you say?
Yes.
At the top, adults were randomly selected.
Yep. So the word randomly selected is used here. So that's the reason why that is simple random sample. Next is a binomial. Is this a binomial requirements? Do we have that requirement?
Mm-hmm.
Yes, we do have a binomial requirement in this case. The reason why is because binomial requirements means we need to know n. Can someone tell me what is n in this case, which is the sample size of the number of observation? What is n in this case?
40?
I'm sorry?
Is it 40?
No, we don't have 40 people. We got more than 40 people.
481.
Not
882.
481. So 481 says in favor. So in this case, and 401 were opposed. So your n in this case is not 481 or 401, is the total of this. So it's 481 plus 401. So that's why this is 882. So make sure you guys know that if sometimes a question gives you how many success, how many failures, so you have to add this up for your n in this case. Okay, so we know n in this case, so that is the first requirement. That's the first condition for binomial. Second requirement is independence. So in this case, people who vote either they're in favor or opposed to the stem cells research, they are independent. Okay, so that means that if you say you're opposed to the stem cells research and the other person is totally independent based on his or her thought, so that is independent. 3, it is 2 outcomes, either you in favor or you oppose it. And the last one is the probability is the same. So that would be 50-50. So in this case, the binomial will work in this case. Can someone tell me what is my X in this case, which we call that as the number of success. Anyone know what is X in this case? Read the claim statement and they will tell you. Yes.
481.
481, yep. The reason why we are not picking 401 in this case is because the claim is asking for those who are in favor. So in favor in this case are 481. So for us to answer the last requirement, we found out that there are 481 success, means they are in favor, and 401 they are failure. That means they are opposed in this case. But as you know that since 481 is more than 5 or more, and 401 is 5 or more, so we did fulfill the last requirement. So there are 3 requirements you have to fulfill here. So in this case, the requirement does fulfill in this case. Okay, so this is how you do your requirement check in this case. Second one we have to do here is your hypothesis statement. Hypothesis statement is where your P, not your H0 and H1 or HA. So in this case, P in this case is equals to 0.05. This is your proportion here. For your null hypothesis, your alternative hypothesis is P is not equal to 0.5. So that is your claim statement in this case. You make sure you use the word, the symbol not equals to, or the word not equal like this. So that is your hypothesis statement. The third one that we have in this case is your sampling distribution. Can someone tell me, is this sampling distribution is a Z or a T? Z or T? Anyone? Z or T?
Z.
Why is Z in this case, Suli?
Because actually, because it's normal distribution.
Yep. So Z is normal distribution, and this is for proportion. So every time a proportion is used, we will use Z. If you're talking about mean, we will use T in this case. Okay. So in StatCrunch, you have to put it down and you have to figure out what is your test statistic will be and what is your p-value. That is what you need to do for the fourth questions here. So in order for you to use your StatCrunch, right here. So you have to do this in your StatCrunch is you go to stats, you go to proportion stat, one sample with summary. So you have to write down this, you have to put this all the informations in there. So what is the, what is the number of success we have for this question number 3 here? Number of success is
481.
481. Number of observation
882.
882, which is the sum of those two up. And then for your hypothesis testing, this is P equals to 0.5 and P is not equals to 0.5. So this is already set up. This is a correct hypothesis statements. So this is your results as your StatCrunch give you. So what is a test statistic in this case? Test statistic in this case is
The Z-stat.
the Z-stat, which is 2.694. From 3 decimal place, and p-value in this case is what?
0.007.
Yep. So this is a p-value. So we are only concentrate on these last two numbers here. So that is a test statistics and your p-value. If I erase that. Okay, so this is a test statistic and p-value. So this is step number 4 here. Now step number 5 is your decision. So anyone know how to make your decision in this case? What's the decision in this case? You're looking at your p-value and your alpha.
We fail to reject.
So p-value in this case is 0.007, right?
Yeah. So it's greater than
Alpha in this case is what?
0.01.
0.01. So it's 0.007 is
No,
less.
it's less than. It's less than.
This
Sorry.
is less than, yes. So what happens if your p-value is less than alpha?
We reject.
We will reject the null hypothesis.
Yeah.
So now we do the conclusion here. So for your conclusion number 6, so you need to figure out if your claim has equality or no equality.
It has equality.
It has equality, the one that you underline or highlight in your yellow here, it says it's equal. So your claim has equality and your decision say we are rejecting the null hypothesis, the one that you just told me in question number 5 here. So can you tell me that since your claim has equality and your decision is to reject your null hypothesis, this is a table we are using here. So which one are we picking here? Number 1,
there is
2,
no sufficient evidence.
number 3. Which one? 1, 2, 3, 4.
So the fourth one.
The 4th one.
Yep.
It says the claim is include
No,
equality.
the third one. The third one. The third one. The third
The
one.
third one, right? It
Yep,
says,
yep.
make sure you guys know which one to pick. It's the original claim includes equality and you reject H0. So you will take the third conclusion. There is sufficient evidence to warrant rejection of the claim. So this is the conclusion you have to copy and to use. So that is sufficient. So the conclusion in this case will be there is sufficient evidence to warrant rejection of the claim that the ... what you should put in this ... here. Spell today. We're going to put in
The original claim.
the original claim, which is the
That the proportion of subjects who respond in favor is equal.
the proportion of subjects that who
You can't just say that you can't just say that the politicians are lying piece of POS.
that will be the next one. So this is the claim that is not the, so that is number 7. So this, the last one here is the question. So we do have a question in this case. So that is question. So 7 is the question here. So yes, so now this is, so do not forget that there are 2 claims here. One is based on the claim that we are, the testing we are doing, and one is the other claim that is based on the politician. So based on this, what can you tell me with the politician claim here? Is the politician claim is valid? So what do you suggest about the politician claim? Is the politician claim says that, yeah, people doesn't really understand what a stem cells issue is, because it's like equivalent to a coin toss. A coin toss means 50-50, like what we did over here. But what do your conclusion says about this? Is that equals to 50 or not? What do you do?
I think the claim is invalid.
So we are accepting the claim or we rejecting the claim?
rejecting the claim.
We are rejecting the claim. So that means that the politician claim in this case is what?
Invalid.
Yep. So the politician claim is invalid. It's because what you written down on number 6 here is where you reject your claim in this case. So make sure you guys know how to do this. This is not difficult. So make sure you understand this, the 7 steps of hypothesis testing. And yes, this was like a lot of points in your test.
Professor Liu,
Mm-hmm.
you know, I want us to, we students to really understand this thing very well. If you look at your alternate hypothesis, hypothesis, it says it's not equal to.
Mm-hmm.
Well, that's what I was asking you last week, that because if you look at your number 2 question, the second question you saw last week, your alternate hypothesis was still the same thing as the claim.
Mm-hmm.
But this one is different. Why is that?
This is something I want to point out to you guys. Okay, so based on the claim, so you know this test the claim. So if your claim says that is less, let's say this is less than 20%, that example, then your how do you write your null and your alternative hypothesis in this case? So P is what? If I use the claim, say it's less than 20%.
P is equal to 0.02 something.
Mm-hmm. And for this case, it's less than 0.02, right?
Okay.
And what happens if your claim is greater than 0.02? Then we use what? Greater than, right?
So why is that?
Oh,
Why
because
you
the
change now?
because the claim says greater than.
Okay, good. I get that.
This claim changed. The claim is
Okay.
based on what you have. So now the claim that I have is not less than, is not greater than, is equal to 20%.
Okay.
So last time less than is this, greater than is that, right? The purple one is greater than. So how do you write your H0 and HA if it's equal to 20%?
H0 is still equal to, then HA is not equal to.
Yeah. So what's your question in this case, Lawrence?
Now, if you go back to the second question you solved last week, if the alternate hypothesis didn't change.
This one?
Yeah, the second question.
Because
you
it's
solved last week.
the claim here says more than. What do you mean by does not change?
Okay, you know what? I'm going to schedule an appointment with you so I can go through it online. Don't worry. Let me not delay the class.
Yeah, because this is more than, so we are using this one because it's more than.
Okay, let's go on. Let's go on. Thank you.
Okay, so class, this claim statement is not determined by me, it's determined by the questions. So the questions will tell you what claim that you have to use. So these are the two, make sure you guys know that the null hypothesis is always equal to. Your alternative is either less than, greater than, or not equal to, depends on the claim statements. Okay, so that is what I can tell you here. So, and the claim statement is come from the question, it's not comes from me. This homework is due on Wednesday, so make sure you guys do this homework here. Some of you restart working your homework, which is good. This homework is due the Wednesday by the 10th. Okay, so this coming Wednesday. So before I continue with 8.3, testing the claim about the mean, let's take a look at another questions on your homework here. This is someone asked me this question here. Where is mine? So in 8.2 here, question number 5. So this is a questions that someone asked me. So again, read this question. And you guys need to figure out what is your hypothesis testing in this case, the now and the alternative. This is 8.2. So where is the claim statements when you read this question? It's very similar to what we just did, right?
The claim statement is that the proportion of subjects who respond in favor is equal to 0.5.
Yep, so this is the claim statement here. Okay. So how do you write your hypothesis and your now and your alternative hypothesis? Is that A, B, C, or D?
A.
Okay, that'll be A. So don't forget, your now hypothesis is always equal to, and since your claim statement says it's equal to, you are testing for not equal to. You guys all right? Next, we are looking for your test statistic. So for your test statistic, you need to know what is your, you need to go to your StatCrunch here. So what is your N in this case, and what is your X in this case? N in this case is your sample size or number of observation. And X in this case is number of success.
N is 516.
How you get 516?
400 and plus 116
400
plus 116.
I got
that's
888
and how do you get 8 something, Casey?
because it's 488 were in favor, 400 were opposed. It says exclude the 116, so I didn't include the 116.
So do we need to include the 116?
No, it says exclude them, so I didn't. So I didn't include them.
So yep, the question says that exclude the 116 people. So in this case, you don't use 116. You just use what? 400 and
88.
488. So what's the total here?
488.
No,
Oh, for N? Or
for N.
X?
For N. N.
Yeah, when N or N is 888, sorry.
And in this case, number of observation is 888, where you take 400 and 488 and add up.
Yep,
Do not include 116. And the number of success, X.
488.
So are we taking 488, 400, or 116?
488.
Based on the claim, we are talking about what? In
Favor,
favor, and how many in favor in this case?
488.
488. Yep. So make sure you guys do this. This is a lot of students did not read the question carefully or did not really pay attention here. Please read the question really carefully. So use your where's my StatCrunch to do this. Wow. So you go to your stats, proportion stat, one sample with summary. So number of successes in this case is 488. And number of observation in this case is 888 because you don't include the 116. And we are using the 50 and not equal to 50. And you compute here. So what is your test statistic in this case? That's a question I'm asking to do. So test statistic in this case is what? In 2 decimal points. 2.95. And the p-value in this case is what? 0.003 in 3 decimal place. And then you'll figure out what is your conclusion in this case. So since your p-value is 0.003, this is your p-value, 0.003, and your alpha in this case, if I read the question, what is your alpha in this case? Anyone, alpha?
0.10.
So it's 0.10. So is this p-value, this is an alpha, it's of 10% significant. Is this p-value is less than or greater than alpha? This p-value is
It's way less than.
way less than alpha. So what kind of we do? Reject or fail to reject each number? We will reject. So that is so your answer is either C or D. And now you do your conclusion here. What's your conclusion says? Do your claim has equality here? Yes,
Yep, it does.
it does, because it says that it's equal, so it has. And you told me you are rejecting your null hypothesis from the decision. So based on the table, so if you refer back to this table again that we have, can you tell me which one are we picking? 1, 2, 3, or 4?
It's 3.
It's 3. So so your answer in this case is there is sufficient evidence to warrant rejection. So can someone tell me which one is the correct answer here? Is that C or is that D? Because we are rejecting. Anyone?
C.
So you'll
It's
be
C.
C. Yeah, because there is sufficient evidence to warrant rejection of the claim. And then they're asking about the politician claim. This is the same thing we say. So the result suggests that the politician is doing his best to accurately portray the feeling. The result suggests the politician is correct. The result suggests the politician is wrong. The results are inconclusive about whether the politician is correct or not. So which one is a correct answer in this case?
It's C, isn't it?
Yep, it's still wrong. Wrong means invalid because you're rejecting the claim. So in this case, your claim in this case is wrong or invalid. You guys all right? You guys doing okay here? So it's very similar to the question 3 that we're doing here. Just be careful how you read the questions because some questions are worded very differently from this one. So just be careful. Okay. So this is for proportion. So today we're going to talk about the mean. So what is the difference between proportion and mean is for proportion, when you look at your claim statement that you highlight, you have the word proportion comes up. If there's no proportion, you have the like a decimals or a fraction or percent, or you can get the word percentage. So if you look at the claim statements, your claim statements has this kind of word, percentage, more than 1/4, the fraction of decimals, or the word proportion. So that's why we know this is proportion. In order for us to figure out it is mean, your claim statements will have the mean word on it, or the mean the word mean on it. So make sure you guys read the question really carefully, which one is which. So for this section 8.3, we are doing population mean here. So there are some variables in this case. N in this case will be your sample size. Or we call it number of observations. Okay, so depends on the questions we have. Okay, that same thing. X bar, we call this as your sample mean. Okay. This mu naught or mu X bar is called your claim value, or sometimes you call it as your test value. Don't forget, this claim value or test value has to come from your claim statement. So remember last time, the equal to 0.5, more than 1/4. This 1/4, this 0.5 is what we call as your claim value. That is written down as mu0, okay, or mu X bar. They are the same thing, so we call it claim value. The letter S in this case is called the sample standard deviation. Okay. Alpha in this case is called level of significance. This is pretty much alpha is the one that we use, and as you mentioned that, as you know that, is always given in the questions. So just put a note for yourself here is it is given a question. If alpha is not given in the question, we will use 0.05%. Okay, so this is a note that you guys need to know. So the same thing happens in the 8.2. So if alpha is not given to us in the questions, we will default as 5%. Okay. Now there are only two requirements here. It has to be simple random sample. Your population is normally distributed, or sample size is greater than 30, or both. So this second requirements that we have here is loose. Okay. What does it mean by loose here is that the meaning of loose in this case is if you have if n is small, okay, so if you have a small sample size, that will be no good here, right? Because usually sample size you need more than 30. So if you have an n is smaller than sample size, then make sure the sample has no outliers. Okay, so you can actually still use the second requirements. If you have a small sample size, like our classroom only got like 15, 16 students, it's small, we can still use that as long as you do a box plot. So the box plot is the one that you need to do here. So if you perform a box plot and your box plot shows no outliers, which is no dots on the end there, it is good. That means you will meet that requirement. However, if you do the box plot and you see you find out there are outliers in this case, in the sample in this case, that means requirement number 2 is no good. So make sure you guys knows this. This is very important. Okay, so if you have a small sample size, make sure you draw me the box plot. In your StatCrunch, you just go to your graph and go to your box plot, and they will give you the dot in the end. Okay. How do we do? What do we do in the StatCrunch? In this case, is make sure you got two choices here. One choice is you do a t-stat with data, and then the other one is t-stat one sample with summary. Again, what is the difference between data and summary? Is data summary means the summary statistic is given to us in the question, like the sample mean, sample standard deviation, sample size, they're all given to us. What is the meaning when you want to use with data? With data means that the questions already provide you the data set, or you import it from your homework, or you use one of those data sets given in the questions. Remember, I give you, when you go to StatCrunch, you got the data set like the bears and from the textbook, like the bears and the body data. So all this, if you use one of this, we're gonna use with data. Or if you have the data you imported from your homework, that is also use data. So make sure you guys, you know which one to pick here, okay? The procedure is the same 7 steps procedure that you guys do in 8.2. First, requirement check. Second, you use the hypothesis testing. You have state your statement here, either the null and the alternative hypothesis. The sampling distribution in this case will be your T. We don't use Z because this is mean. And then you will use your StatCrunch to find the p-value and the test statistic. And then after that, you look at your alpha, the level of significance, and then you figure out if your p-value is less than or greater than alpha, reject or fail to reject. Same types of conclusion. This is just all copy and paste from the 8.2. And then don't forget to answer the question. So number 7, in this case, we do have sometimes you have to answer the question. Again, depends on the question. If the questions have questions, then you answer it. Otherwise, if they don't have the answer, the questions, you don't need to answer it. And again, how we answer the question here, if you pick the first conclusion, then your answer in this case is yes or valid or true because you are supporting your claim. If you answer the second one because you are not supporting the claim, then your claim is invalid, is wrong, is not true, and so on. If you answer the third conclusion, this is also no or invalid answer. Okay. The reason why it's no or invalid here is because you are rejecting your claim, which is the same thing as not supporting your claim. And if you answer if your answer is the last conclusion, then it's a yes or valid claim because you got the word no and the word rejection, which is a double negation that will cancel each other off. So it's a very similar stuff that you guys did in what we have here, what you did in 8.2. The only difference here is make sure that this is mean. So this one has units. So be careful when you write your hypothesis statements here. Make sure that you put units in here. So last time we don't have to have unit because proportion has no units, it's decimals. But for mean in this case, you won't have decimals. Okay, so very similar to what you guys did before, just a little bit off, a little bit different because it's mean. All right, I want you guys to read the first question, and as usual, you need to find me your claim statement. Anyone got a claim statement for number 1?
The mean speed of all cars is greater than the posted speed limit of 65 mph.
Yep, that will be the mean. That is a claim statement. So you can see the difference here now is the word mean shows up. You see that? And last time we used the word what? Proportion. So that is how you differentiate between 8.2 and 8.3. So we have the word mean here. So we will go through our requirement checks here. So that's the first we have to do is checking a requirement. So the requirement check we have is first simple random sample. And second requirement check is your population is normally distributed, or your sample size is more than 30. So don't forget, this is an or statement, means that you need to only fulfill one of these conditions. So my question is this simple random sample?
Yes.
And it's stated in the question right over here. Okay. So you have to be stated in the question. Next is your population is normally distributed or your sample size is more than 30. Do we have that?
Yes, it's 40.
Yep. So since your sample size in this case, you have 40 cars here. So this will fulfill, although is this normally distributed? No. In order for them to say this is they have to say this out loud, that the population is normally distributed in your question here. So since this is no, but you have more than 40 samples, so it's yes. So it's a or, means one of them is good, so it's good. So in this case, we do fulfill your requirements. Okay, so make sure you know that this is an or statement here. So the second thing is to write your hypothesis testing. So in this case, there is a little bit change on your hypothesis testing statements when you write this. Last time we used the letter P to symbolize as proportion. For this case, we don't use P, we will use mu, the symbol mu. So we make sure you guys know this. That's a little bit different, but not too much different. So mu means for mean, P is for proportion. So can someone tell me how do you write your statements in this case based on your claim statement? Says that
Would be equal to 65 miles per hour.
so this is equals to 65 mph. So the only thing is make sure you put units on here. And what is the alternative hypothesis?
Greater than 65 miles per hour.
Yep. So that is the only different. I mean, it's very similar to what we did on proportion. Two things that is different. Make sure you change the P to mu, and then make sure you put units at the end. The third one is your sampling distribution. So what is your sampling distribution in this case? Is that a Z or a T?
T.
This will be T because it's mean, so we will use T in this case. Next, we're going to talk about is doing your stack crunch here. So you need to find your test statistics and your p-value. So in order for us to find your test statistics and p-value, you go to your stack cruncher. But which one are we doing, with data or with summary?
Summary.
So this you have to use with summary. So the reason why you're using this with summary is because the questions are giving you all the summary statistic, the mean, the sample mean, the sample standard deviation, and so on. So what you need to go is you go to stats. So using your StatCrunch, go to your stat, go to your t-stats, go to your one sample with summary. So this is what you need to do for these questions. So they will ask you to put down this. So can you read this question and tell me what is your sample mean is, what is your sample standard deviation, and sample size?
$68.4.
Yep, that is the sample mean, 68.4.
5.7.
Is the sample standard deviation. And sample size?
40.
40. Now, what is the claim value? That claim value is the one that you put under the hypothesis testing. What is the claim value in this case?
0.65.
65. Okay, not 0.65, don't forget, this is 65 miles per hour. And the claim value is always in the claim statements, okay? So make sure you, and we are testing for greater than 65 because the claim statements tell us to test for greater than 65 because those are people who speed, right? Because if you go faster than 65 miles per hour, I will pull you away from a policeman. So let's compute this. And again, the thing you notice here is the last two is your test statistic and the p-value, and no longer z-stat here. This is a t-stat, and that's why this is where the t came from with number 3. The sampling distribution is from t-stat. So what is a test statistic in this case? It is 3.773 or 23, and the p-value in this case is 0.0003. Okay, so this is your step number 4, where your results from your StatCrunch, and the typical same step 5 and step 6 here, which is decision. So what is your p-value? The p-value is 0.0003, and alpha in this case, alpha is given to us by 0.05 in the question. So what you guys can tell me with this p-value and alpha, less than or greater than here? P-value is
It's less than.
this number is less than. So what is your decision? Reject or fail to reject?
Reject.
You reject. Yep. So that is your decision is to reject him. So the last thing we're gonna talk about, conclusion is the next thing we're gonna talk about. Do your claim has equality or it has no equality? So the
Has
claims about
equality.
it does not have equality because the word
You know,
greater.
the top one? Oh, okay.
Yep.
Thank you.
So again, every time, that's why I want you guys to highlight that the claim statement, because that is the determinant of what you pick here. So since the one that you highlight is used greater than means it's not the equal sign. Okay. And the decision you use is reject H0 from number 5 here. Okay. So which one are we picking for your conclusion here? You say your claim does not have equality, and you are rejecting the null hypothesis. Is that 1, 2, 3, 4? Which conclusion?
It's 1.
So it's the first one because you reject and no equality. So your conclusion in this case is there is sufficient evidence to support the claim. So we are using the first conclusion in this. So there is sufficient evidence to support the claim. That then you just copy and paste from your claim statements that you highlight or underline. The mean speed of all cars is greater than 65 miles per hour. Okay. So if I'm a policeman, I will be gonna be in this highway 405 for a long time because I'll put a lot of speedy drivers, because based on this, there are a lot of cars driving faster than the speed limit. Questions? This question has no number 7, so you can skip number 7 here. So so this one you can skip it because this question doesn't have a question. Anyone? Good. Questions for me? Very similar to 8.2, right? A little bit different, but pretty much the same 7 steps. All right, I want you guys to read question 2 on your own. And this is from body data. So it's from the file name body data. So it's on body data, this file name. Okay. So if this is the file name for body data. And we want to just do adult females. So gender in this case, if you look carefully, it says 1 is male. So that means that your gender in this case, you pick 0. Okay. So when I say, so if you look carefully on here, oops, sorry, where was my little table? There you go. It's written down here that your gender is one is M means male, and then 0 means female. So in this case, we are concentrating on females on the pulse rate. So we are looking at the pulse rate for the females. So our first thing class is I want you guys to go over, read this question, very short question here, and they should have a claim statement. I want you guys to underline or highlight the claim statement as usual. And then go through the whole 7 steps of what we did up here. Okay. Go ahead and do it on your own. Treat that like a test. The test question looks very similar to that. I want you guys to do the first 1, 2, and 3. Requirement check, statements, and sampling distribution. Step 4, wait. We'll do it together. So the first question is requirement check. Is this simple random sample? Yes or no?
Yeah. Yeah, because you said,
No.
yes, because you said
Wait,
that
yeah.
all of that is SRS.
Yep.
From
so
the
as
data.
what? Yep. Casey, you're correct. So all the data set from the textbook here, every single one of this, the author actually do this by randomly selection. So that means this is automatically yes. If they pick any files from this, you're correct, Casey. Okay. Is this population is normally distributed or data size, your sample size is more than 30? So how many females do we have? There are quite a lot, right? How many data here? There's almost like 200 data. So you think there are more than, you got 30 zeros here or more? Look at that. If you keep, I can keep on scrolling down this data set. Do you think you got more than 30 of these zeros? Because zeros means female. Do you need to count them?
I don't think we do.
Yep. Do you think it's more than 30
Yeah.
females in here? Oh, yes. Right. So in this case, the requirements is, if you want to count, you can count, but the next, if you want the next, I'll show you, you do not need to count it because there is a way for us to do it. So let's do the hypothesis statement. So go ahead. I want you guys to try to, oh my goodness. Oh my God. Don't use the tab statement. Write your hypothesis statement in this case, H0 and HA or H1. I am not picky. And make sure you guys understand H0, H1, HA, H1, they are the same thing. I don't want to use HA or H. Make sure you have the mu symbol. So can someone tell me, oh, I forgot the claim statement. Where is my claim? Anyone know what's a claim statement in this case?
The mean is less than 75 BPM.
Yep. So the mean is less than 75 BPM. So what is the statements in this case?
Mu is equal to 75 BPM.
Yep. And HA,
Mu is greater than 75 BPM.
again, the claim statement is asking us to prove what?
I got less than.
Yes, it's less than 75.
Good. So at this point, it's not changing. The alternative statement is not, alternative hypothesis is not changing.
No, okay, Lawrence, I want to point out to you that if the claim is asking us for less than, you use less than.
But in proportion, did it change?
No,
Okay.
Can I ask Lauren something?
Yeah, please.
I'm confused as how to you automatically, like when you read the sentence, you automatically switch it to the opposite. Like I don't, like where are you getting that from?
Can
Because
I-
I'm getting more and more confused.
Can I try saying something too after?
yes, Armin, you can chip in, yes.
When we were in class last Wednesday, I feel like Lawrence, you were getting confused just because it's called the alternative hypothesis
Yeah,
doesn't mean it's like flipped.
Okay.
The HO is always equal, right?
Yep, yep.
And then the other one, it's whatever the claim says. Is kind of how I've been understanding it.
That is
Okay.
correct, Armin.
that's what I
Okay.
understood it too.
Yep, Casey. So,
Okay.
Lawrence, I just want to point out to you the word alternative hypothesis is not opposite of the claim state testing.
Okay, okay. Thank
You got what I'm saying here?
I do get it now. Thank you.
Okay, so you just
Okay.
follow the whatever the claim statement wants you to do. If it's less than, you use less than. If it's
Okay.
greater than, you use greater than. Don't
Okay.
change to the
Okay.
other
Okay.
direction.
Thank you guys. Thank you guys. Thank you.
Mhm.
Thank you for.
I think you got it now, Lawrence. Okay?
Yep, yep.
And
yep,
if you
yep,
change it, everything is gonna be wrong.
yep.
okay.
Thank you.
Don't do that. Okay. Thank you, Casey and Jamin to clarify this to Lawrence. So yes, this is also for the people who didn't catch it. Make sure you know that. We just call it alternative hypothesis. Doesn't mean you have to change your symbols. Okay, so don't change it. The sampling distribution is a T. The reason why is because we are doing mean here. So far, everyone following? Lawrence, are you okay?
I am now. Thank you.
Okay, good. Because I want everyone on the same page. So when you guys do it in my test, don't do something crazy. That will be like, what are you doing? Okay. Is this with summary or is this with data?
Data.
Okay, so this one is with data. The reason why is because we're using data here. Okay, tons of data here. So the fourth step here is figure out what is your test statistic in this case. So in order for us to figure out this, we have to go to stats, T-stats, one sample with data. Last time we do with summary. And we're gonna select pulse rate because we want to figure out what is the pulse rate. Now, if you just do this, it means we want just everyone pulse rate. But this question, we only concentrate on female pulse rate. So then you have to group, okay, by gender. So you have to group by gender. So this is what you do in this case, if you want to split this in, because we've got two gender, male and female. So we will still use pulse rate here, and then you group it by gender here. And the hypothesis, the claim value or test value in this case is 75, and test says, the claim says you have to test it for less than 75. So this is the way that we pick here, and you hit compute. Okay, you guys all right? Okay. And there came out two because one is 0 and one is 1. So since we are doing for the female, we are only concentrate on the 0 ones. Okay, that is the female pulse rate. So the test statistic for this case is this one, negative 0.927. And the p-value in this case is 0.171777. You guys all right here? Questions with this? All right. I want you guys to do question step 5 and step 6 on your own, which is the decision that we'll be using. Okay. So I want you guys to do it on your own, decision and conclusion. This is very important. Please try this on your own.
I think it's fail to reject.
Okay. Okay, that's good. So the p-value in this case is greater than alpha, which is 5%. Because alpha is 5%, this number is greater than. And yes, your decision is fail to reject. You are correct. The null hypothesis. And since the decision is fail to reject the null hypothesis, so this is a little bit different from the one that we always do. And the claim, do the claim has equality or no equality?
No equality,
Because the claim says is what?
less than.
Less than, so it's no equality. So back to the 4 conclusions that we have, 4 choices here. So can someone tell me which one should be used where your claim says no, does not include equality, and you fail to reject H0? 1, 2, 3, 4.
It's number 2.
Yes, it's number 2. So where this does not include equality and you fail to reject H0. So we're gonna take the second conclusion here. There is not sufficient evidence to support the claim. So we're gonna write down over here. There is not sufficient evidence to support the claim that the mean is less than 35 beats per minute. You guys all right? Question? Anyone have any questions for me?
I get confused when it comes to the fail to reject and the reject.
So
Like, I
you,
get everything else. It's just that those 2 wording of the fail and the reject itself.
so depends on the p-value and the alpha. Okay. So the p-value should be less than or equal to alpha, then we will reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. So it depends on the p-value
Mhm.
and the alpha. So in this question number 2, the p-value in this case is 0.1777,
Yeah, I got
and the
that.
alpha is 0.05.
Yeah.
So that means that this is greater. The p-value is greater than alpha.
No, I understand that. I guess I just don't, I'm not getting the whole failure to reject and just the rejecting it in general? 'Cause they're both
this is kind of like a formula here.
yeah.
So it's fixed.
Okay.
This is fixed. That's why this is
Oh,
so this is fixed. You
Okay.
cannot change it. It's kind of like a formula.
oh, okay. I see 5.
Okay, number 5. So this is fixed. You cannot change this form. This is there.
It's an automatic. Okay. I keep
Yeah, it's
forgetting.
automatic. So
Okay.
you cannot
All right.
switch them around.
Okay.
Mhm. Questions, anyone? Question 2. You guys are doing really well, actually. All right, try number 3 now. Number 3 is down here. So very short. So read question 3. Highlight or underline your claim statement. Very short. It's a claim statement. Same thing in your test. I will always give you the claim statement. And this one has no number 7 because there's no question.
The mean age of all race car drivers is equal to 30 years.
Okay, good. That will be your the mean age of, yep, this is your statement. Very good. So what you need to do for me here, class, is please enter all these numbers into var1. So go to your StatCrunch, enter that. When you do this in your online homework, you can export it to your StatCrunch, so you do not need to enter it. However, in your tests and in your test and in your in your review, you actually literally have to enter them, like what I just did over here. Make sure you enter them the correct number. And again, make sure you, once you enter, make sure you go through the whole 7 steps of hypothesis testing here. So check the requirements, write your statement, tell me the sampling distribution, 5, 6, 7, 1 to 7. Try to do this on your own. So let's talk about your requirement check. Is this a simple random sample?
Yeah.
Yes, it's in the question. Right. Randomly selected right here. Is this population is normally distributed or your sample size is more than 30? This case, you find out that your sample size is what? How many people they pick here?
It's less than 30.
Is less than 30. It's only 15 people. If you look at how many you enter, there are only 50. So your sample size in this case is small. So this is the problem because if you have a small sample size, the requirements for number 2 says that you need to have at least 30. But if you have a small sample size, make sure that the sample has no outliers. So what you need to do is draw me a box plot. So you go to the graph and you go to the box plot. and you draw the var1 in this case. Okay, it doesn't matter, you go horizontal, vertical, because the main part in this case, we want to figure out, do we have any outliers? And you hit compute. Do we have any outliers in this case?
Yes, and I mean, if you just look at it, you can kind of tell there is going to be an outlier
Ah.
without even doing it.
Casey, I better not want you to look at it. Just make sure you draw the box plot, because sometimes your eyes is misjudgment. Okay, so don't do that. This is one of the mistakes students tends to do in my test. Oh, let me look at the data. Oh, that's 52. Oh, so try not to do that. Okay, because the reason why I say it, because I can tell you that students, I recommend just do the box plot. Okay. So since the sample size is small and the box plot shows outliers, right? That's one outlier, right? An outlier. So in this case, this will not meet. Okay. So in this case, the requirements does not fulfill. You guys all right? You still need to continue doing 2, 3, 4, 5, 6, 7, all these numbers you have. Although your requirement does not fulfill. Okay. So again, Casey, or the rest of class, not just Casey, so just look at them and eyeball yourself. Recommend you to just draw the box plot out. I mean, not draw, like do the box plot. Then you get 100% for sure.
Okay.
It's just very technical in this case. All right.
No. Yeah.
You know what I mean. I know, Casey. I know you know what I mean. All right.
So I have a question.
Mhm.
This one, it hit like a couple of requirements. I mean, like one of the requirements, right? It's not fulfilled. So are you still asking us to keep going or? Okay.
Yep. You have to keep going.
Okay.
But for your real world, your real research, your real project, your real thesis, no. But for my class, yes, you keep going because you're just starting learning this material. Yeah. Once you take a few more stats class, then then we should know what to do here. But in your class, unfortunately, we have to keep going. That means your results is not going to be correct because of the requirements fail in this case. You will learn this. This is the intro stats class. Okay. There's so many stats class. So since your claim statement says is equals to 30 years, so that will be 30 years old. Your alternative is not equals to 30 years. And the sampling distribution will be T in this case. That will be your third steps here. Four steps is we have to use your StatCrunch. Is this with data or is this with summary?
Summary.
What's the difference? Summary means I give you the mean, standard deviation. Do this question give you the mean, standard deviation, sample size?
No.
So this question actually gives us what? Data. So this is going to be with data. Yep. So go ahead, use your StatCrunch and do this. Make sure it's var1. You have to enter all these numbers. I am also taking attendance right now, so go to the chat room and you know what to do. I can tell you there's no question on number 7, so we can skip this one. Go to stats, t-stats, one sample with data. And we're picking var1 as our data. And we are testing for 30 years. So 30 years is what we need to use. So it's equal to and not equals to. And you hit compute. So this is your test statistic here and your p-value. So test statistic in this case, 1.818, 1.82. P-value is 0.0905. So the p-value we get is 0.0905. And the alpha is given in the question 5% or 0.05. So the question is p-value is what? Less than or greater than?
It's greater than.
So what is the decision we're gonna make?
We failed to reject it.
Yep, fail to reject. So now reading the claim statements for the conclusion here. Do the claim statement has equality or no equality?
There is equality.
Yep, so claim statement has equality because the word equal is used. And your decision you found in number 5 is fail to reject. So now you need to look at the 4 conclusions that we have, the table, and you need to pick one of this. So is that 1, 2, 3, 4? Which one is the one that we pick for this question?
Number 4.
Number 4, equality, and you fail to reject, which not. So there is not sufficient evidence to warrant rejection. So we're going to use that 4th conclusion here. So there is not sufficient evidence to warrant rejection of the claim. That the mean age, can I spell it out, all race car drivers is equal to 30 years old. 30 years. And then we can skip question 6, 7 because we don't have a question. You guys all right? Now you're doing this for quite a few times. You guys get a bit confidence now to do a hypothesis testing. Make sure you guys practice this. This is quite important. Questions for me before we do the last question here? All right, for the last question, we are not doing a hypothesis testing on question 5 because this question did not want us to do a hypothesis question. This question wants us to find the p-value, okay? So in order for you to find the p-value, you have to, if the question is asking you to find the p-value, make sure you go back to 8.1, the second table, okay? So if the question is asking for to find p-value, make sure you use 8.1 table number 2. Okay, I will show you which table it is. So there is a claim. So as usual, no matter you find p-value or hypothesis testing, there is a claim. And the claim says that the mean in this case is equal to 98 points. Oh my goodness, I should have. The mean is equals to this. Okay. So can someone tell me, is this a one tail test, a left tail, a right tail, or a two tail test if you do this? Is that a left tail, a right tail, or a two tail?
I think the two-tail test.
Equal is very similar to number 3 here, right? Where you do equal and not equal. So this is a two-tail test. So make sure you guys know that this is a two-tail test because we are doing equal, not equal to. If you're doing less than, this is left tail because the arrow points to the left. If you use greater than, it's a right tail because it's pointing to the right. So this is going to be a two-tail test because it's an equal here. Okay, and we are talking about mean. Okay, so now I'm going to show you what is the 8.1 table 2 looks like. So if you have your notes, you just like me scroll or go to the 8.1. So 8.1 is this. This is 8.1, and we got two tables. Table 1 and table 2. So table 1 is to find critical values. So if you do any homework in the future, 8.1, 9, 9, whatever in the future, if they ask you to find critical values, make sure you refer to 8.1 table 1, which is this one. And if a question is asking you to find p-value, then make sure you look for table 2, the one here. So since we are looking for p-value, we are looking finding table 2. We are looking for mean because this this question that we did here is talking about mean, and you told me it's a two-tailed test. So what you need to, in order for you to find the p-value, you have to use your t calculators. This one that I highlight in orange. So you go to your stats, go to your calculator, go to t calculators. Then we'll do the degree of freedom later on because we need to read the questions. I didn't read the questions yet. Make sure you put x is greater than, and then you forget to double it. Okay, so make sure you double it. So I will show it to you how we do quiz question number 4 here. So now we can read this. So we how many sample size here? Sample size in this case is 4. So we're gonna use a t calculator here, where your degree of freedom in this case is n-1. So don't forget the formula is always n-1 for this case. So make sure you guys know this. 4 minus 1 is 3. So you have to change this into 3. Okay. And then you will, now since your test statistic is negative, so this is something you need to watch out here is if your test statistic is negative, you actually use less than. Okay, so let me little note here for yourself here, very important. If the test statistic is negative, you use less than. If the test statistic, because either you can get positive or negative, positive, yeah, it's positive, you will use greater than or equals to. Okay, and then we will put this test statistic in here, negative 2.03. So in this case, you have to take p x less than or equals to, because is negative 2.503, and you make this blank. Okay, so in your StatCrunch, this is what you need to type in. So degree of freedom is 3 and -1 because we got 4 sample size. Negative x is less than negative 2.503. This is a test statistics. and you hit compute. So this number in this case, oops, sorry, it's right here, is gonna be 0.04373752. I just write off these numbers. However, this is something you need to know because this is a two-tailed test. You have to double, okay? Because this is a two-tailed test. The p-value will double. So in this case, yep.
When it comes to your test and it comes to something like this, do you want us to use the whole thing and multiply by 2, or do you want us to
No
round
need.
it off?
Just round off and multiply. But your online homework, they want you to use the whole thing. That his online was picky.
Okay.
But for my test, I know what you do. 0.04373752, and then multiply this by 2. Now you can round here. So so in this case, your p-value will be, oops, sorry, I need to do it again. Shoot, I am sorry. 0.04373752 times 2. This one 0.8. So in this case, your p-value is 0.0874. So this is how we figure out for this case. And don't forget, if it's only left tail or right tail, then you do not need to double it. Then your answer is just this 0.0437, whatever this number is. Okay, so make sure you know that if it's a left tail, make sure you use less than or equals to, because of t-stats, your t-stats is negative. If it's a right tail, your t-stats usually is positive. So you do not need to double it. You just use the probability that you got here. However, if you have two-tailed tests, you will have to double it. Means that two-tailed test means your p-value is on both sided and they are symmetrical. So the left and right having the same number. So you have to double. Anyone have any questions for me? This homework is also due on Wednesday, the 10th. So there are 2 homework due on this coming Wednesday, which is 8.2 and 8.3. Anyone have any questions for me?
Could you please show me how you did the box plot one? The other question.
You type in the, sorry, give me a second. You type in the number in var1, and then you go to graph, you go to box plot, and then you select var1, and then you hit compute. Okay, and then you got a little dot here, and that is your outliers. Anyone have any questions? And as what Casey mentioned, I do not need you to take all this number times 2. It's just for your online homework. I'm not as picky as your online homework. I'm happy if you know if you remember to double it. Questions? So for me, mostly on your, this is going to be in your finals here because this is all coming up. I am mostly looking how you understand the concept. So even though you give me the wrong, even though you calculate something wrong here, you give me the p-value is wrong, make sure you still continue making the decision and the conclusion. I know it, if the p-value is wrong, definitely everything here is wrong, right? For me, when I grade your finals on this type of question, on this hypothesis testing, I want to figure out how you understand the concept. Although, you did something wrong, in something else you did wrong, I still want to look, how do you make your conclusion? Is your conclusions the correct conclusion based on the wrong p-value that you did? I know it's wrong. So this is something that I'm looking at when I grade at your test. I'm not looking exactly like, this is the answer for everything. The p-value has to match. No, if you get a wrong p-value, I will know the decision and conclusion is going to be wrong, mostly because your p-value is wrong, then I will look at what kind of, do you get the correct, so do you got the concept? That means, are you picking the correct conclusions out of these 4 of them? Okay, so this, you still get lots of points if you make a tiny mistakes here. And it has a domino effects, because if you get one wrong, everything after that is all wrong. But I will not deduct a lot of points because of domino effects. I will still continue doing, using your wrong answer, and I will still continue working it out with you. So, so make sure you guys know that when I grade your test, I'm grading so that you understand the concept, not necessarily get everything correct. I mean, everything correct is definitely, perfect, right? So, but if you did something wrong, continue work out what you did and don't get frustrated. Don't erase, like, how do I do that? Just make sure you project I'm grading your work based on your knowledge, okay? Your concept and your knowledge. So you probably get 1 point off out of 10 points. If everything is correct and you make a tiny mistake, I wouldn't do that. But if you make a mistake here and then your decision is wrong and your conclusion is wrong based on this, the whole thing is wrong, then yes, I will start taking a lot of points off. But if you just make a tiny mistake and the rest is wrong because of the tiny mistake you make, you still get lots of points in your test. You guys understand what I'm trying to say here? All right, so I'm going to end today's Zoom here. So if you have any questions, we will stay back. If you don't have any questions, you may leave. There is also an option for you to do Zoom for your Wednesday class. If you are interested on the Zoom on Wednesday class, please email me, and then that means you didn't come to face-to-face in the classroom. There is a Zoom. There are some disadvantages of that. One of the disadvantages is you cannot chat with me, because when I teach on the classroom, if you type something in the chat room, I cannot see it. The only time you can talk to me is you raise your hand. You guys know how to raise your hand in your reaction. Raise your hand, and then I can see it, and then I will say, all right, David, what is your question? And you have to unmute yourself to talk. So that is the only downfall for doing Zoom in classroom. So so it's very difficult. If you type something in the chat room, I cannot see it. Okay, that is what I heard from the staff. So if you guys are interested in coming on Zoom, I still have a face-to-face class on every Wednesday. But if you think that you are snowing or whatever else, I cannot come to Wednesday class. If you want to come to the Zoom class, it's still going to be the same Zoom login, which is the same link that you would use here. But there are some stuff that you cannot do. One of them is, I know the chat room will not be able to